Hello, my dear friends. I am Dr. Tito, a Finnish word meaning knowledge. I always remain in search of knowledge, and I want to share with you what I have learned so far.
So far, some basic aspect of quantum mechanics as per AICT syllabus. Now our target is to discuss the next part, that is the molecular orbital theory of the diatomic molecule. And during this discussion, we have to draw different kind of molecular orbital, different kind of energy levels for the molecular orbitals for different diatomic species. Now, before going into that, you have to know what is molecular orbital. In the molecular orbital theory, the constituent atom of a molecule are supposed to lose their individual control over the electrons, and their nuclei are supposed to provide a combined field, which ultimately determines the energy of the electrons. Different atomic orbitals are combined with each other, fulfilling certain conditions to generate different molecular orbitals. What does it mean? Actually, in case of atomic orbital, you know the electrons of the atom remain in atomic orbital and their behavior is controlled by the nucleus. But when different atoms combine among themselves, the new molecule will be formed, and in new molecule, the individuality of the atom is lost. That is, the nucleus lost their individuality, and different nuclei will combine themselves to generate a common field, and on that common field the electron will reside and will control by the combined field of the nucleus. Now, where actually electrons stay in molecules. The atomic orbital actually combine themselves to generate different type of molecular orbitals fulfilling certain conditions, and this is the very basics. So what is the molecular orbital? Molecular orbital is nothing but the combination of the atomic orbitals. In case of the atomic atom, electron reside on atomic orbital, and in case of molecules, the electron stays in molecular orbital. And in case of atom, the behavior of the electron in the atomic orbital is controlled by the individual nucleus of that atom. But in case of molecules, different nuclei will combine each other and will provide a common field, and the behavior of the electrons in the molecular orbital of a molecule will be controlled by that combined field. This is the molecular orbital. Now, what are those conditions that must have to fulfill to form a molecular orbitals from the atomic orbitals? We are now coming into that point. Now, before going to that, I am telling about myself. I am Dr. KS, that is knowledge seeker, you know, and I actually discussed different aspects of chemistry, and especially I am now discussing the chemistry syllabus as per the AICT curriculum, and particularly I focused on the syllabus of the chemistry paper for the Maulana Abul Kalam Azad of technology, that is MAKAUT. Okay, so my dear student, so at first you have to know what are the conditions that the atomic orbital should fulfill to generate a molecular orbital. Now, the condition 1, the atomic orbital must have the comparable energies. The atomic orbitals must have comparable energies. We must have comparable energies. That is, the atomic orbitals should have approximately same energy, and only but if a atomic orbital have much higher energy and other one is the very lower in energy, they will not combine. They will have almost equal energy to form a molecular orbital. Number 2, they must overlap appreciably. They must overlap appreciably. They must overlap appreciably. If the extent of the overlap is very small, then the molecular orbital will not be formed. Number 3, they must have the same symmetry with respect to the bonding molecular axis. They must have the same symmetry with respect to the bonding molecular molecular axis. Okay, these are the three conditions. Now we have to learn something before proceeding into the more detail of the molecular orbital theory for the diatomic molecules. What are those? Just remember these few things. I'm clearing the canvas. Just please wait for 1 minute. Just it's not working. Yes. Okay. You have to remember few things. Number one, the number of the molecule are always equal to the number of the participating atomic orbital. The number of the molecular orbitals will be same to that of participating atomic orbitals. Now, in case of even number of the molecular orbital, number two point is in case of even number of atomic or molecular orbitals. You know the number of the molecular orbital will always be same to that of the participating atomic orbital to form the molecular orbital. So in case of even number of the molecular orbitals, so the atomic orbital will also be the even number. We can say anything. I'm now talking that the number of the molecular orbitals, if be even, then half of the molecular orbital will be the bonding molecular orbital and remaining half will be the antibonding molecular orbital. So for even number of molecular orbitals, half will be bonding and the remaining half will be anti-bonding molecular orbitals. Okay, and for odd number of molecular orbital, what will happen? For odd number of molecular orbitals, what will happen for odd number? One will be non-bonding MO, and remaining orbitals, and for remaining orbitals again half will be bonding and other half will be anti-bonding M. Here, for odd number of the molecular orbitals, one will be the non-bonding molecular orbitals, and for the remaining orbitals, half will be the bonding and other half will be anti-bonding molecular orbital. So this is something you must have to remember, and also you have to know what are the definition of the bonding molecular orbitals and anti-bonding molecular orbitals. And I think you know from your higher secondary knowledge. Still I am repeating since all these are included in the syllabus. So just wait. I am trying to clear the canvas. It is not working. Just 1 minute. Yes. So now you have to know what is meant by the number one bonding MO. Bonding MO. That is bonding molecular orbital. What is meant by the bonding molecular orbitals? Now the molecular orbitals may be of three types. One is the bonding, another is anti-bonding, and lastly one is the non-bonding molecular orbitals. Now if the energy of the bonding molecular orbitals be lower than the corresponding atomic orbital, then that molecular orbitals are said to be bonding molecular orbitals, and in case of energy higher than the atomic orbital from which they have been formed, those type of molecular orbitals are known as the antibonding molecular orbitals. And if the energy of the molecular orbitals be same with the atomic orbitals from which they have been formed, that type of molecular orbitals are known as the non-bonding molecular orbital. So I am writing down this, that for bonding molecular orbital, what will happen? The molecular orbital, the molecular orbital whose energy is lower than the corresponding atomic orbitals from which they have been formed are called bonding molecular orbitals. For antibonding molecular orbitals, everything is same, just anti-bonding molecular orbital. Everything will be same, but here we have to write the bonding, the molecular orbitals whose energy is greater than the atomic orbitals from which they have been formed are called antibonding MO. Antibonding MOs. And lastly we have to know about the non-bonding molecular orbital. Just 1 minute, I am trying to erase out things. Yes, lastly it is non-bonding MOs. Now, what is non-bonding MO? The molecular orbital orbitals whose energy are whose energy is equal to the atomic orbitals forming them